Good evening, student, and good evening to all viewers. Welcome to yet another data analysis and interpretation course. I am your instructor, Richard Kofi Aswabi, from the Ghana Communication Technology University, a business school, and more specifically from the Economics Department. Today, we'll be looking at pair sample t-test. As usual, my outline will follow this pattern. Understanding the pair sample t-test, common uses, data requirement, sample data to be used in class. The sample underscore dataset underscore 2014.SAV, which is the extension for SPSS. Remember, I always tell you, I do not own the right to this data. And thanks to Kent State University, where I picked the data from, I can use it for my tutorials. Again, after the data, I will look at the procedure and then the most important, the interpretation. Definition. The pair sample t-test is used to compare the means of two measurements taken from the same individual, object, or related unit. Remember, compare the means of two measurements taken from who? The same individual, the same object, or related unit. What are some of the examples? A measurement taken at two different times from the same individual. For example, the pre-test and post-test score with an intervention administered between two time periods on the same individual. Or we can see a measurement taken under two different conditions, control and experiment condition, and this measurement must be taken from the same individual. What is the purpose? We use it to determine whether there is a statistical significant evidence that the mean difference between paired observation is significantly different from zero. Remember, the pair sample t-test is a parametric t-test. How is it also known? This is known as the dependent t-test, the pair t-test, the repeated measure t-test. The variable used for this test is known as dependent variable or test variable, which is a continuous variable and is used to measure. It measures at two different times or two related conditions or units. Common uses. The pair sample t-test is commonly used for statistical difference between two time points, two conditions, two measurements, or to match pairs, change score, and so on. Note, you can only use it to compare the means of two and only two related pairs of units of a continuous outcome that is normally distributed. It is not appropriate for analysis involving unpaired data, and also for comparing data that are not normally distributed and an ordinal or rank outcome. Remember, the difference between ordinal or a, a rank outcome and a nominal outcome. Again, alternative. To compare or pair means between two independent groups on continuous outcome that is normally distributed, we choose the independent sample t-test. To compare unpaired means between two independent groups on continuous outcome that is normally distributed, we choose what? The independent sample t-test. We have already encountered the independent sample t-test. If you've not watched the video, please try to watch the video to understand more. And if you want to compare unpaired means between more than two on a continuous outcome that is normally distributed, you choose ANOVA, analysis of variance, or the one-way ANOVA. Now, to compare paired means of continuous data that are not normally distributed, we use a non-parametric Wilcoxon signed rank test. Very important. And to compare paired means for rank data, which are not only normally distributed, we choose the non-parametric test, as I've already said. Again, what are the data requirements? You must have an independent and dependent, you must have a dependent variable, which must be what? Continuous, interval, or ratio. Again, note that the pair variable must be recorded in two separate variables. I will explain as we move on. There must be what? Related samples. Again, random sample of the data is very important from the population. The data must be what? Normally distributed. That is approximately different between, there must be some differences between the pairs. There must not be any outlier. Now, note, when testing assumptions related to normality and outliers, you must use a variable that represents the difference between the pair, not the original values variable themselves. So in order to test the pair assumptions, you must use a variable that represents the differences. So what that is telling you is you must look for the differences between the pairs to test these normality and outlier assumptions, not the variables themselves. And if these assumptions are not met, then you use the non-parametric Wilcoxon signed rank t-test. What hypotheses do we test? And how do we test them? Remember, we have the null and alternative. The null says the population mean of the first variable from the individual is the same as the population mean from the second variable from the same individual. So, for instance, the test condition taken from the individual, the population mean, and then the post-test condition taken from the individual must be equal. Alternative says they are not what? Equal. Now, just as I keep saying, this is not a quantitative class or a typical statistics class for us to be calculating the t-test. But I try my best to put the formula there. For those who want to do further calculations, you can watch my other videos which deals with typical calculations. But in this class, it is going to look at the interpretation and assumes that you have some level of knowledge when it comes to pair sample t-test. How do we run the pair sample t-test? Click on Analyze, Compare Mean Pair Samples t-test. Then it opens. Remove the variable to the right by selecting them in the list and click on the blue buttons. Specify the pair variables in the pair variable area. That is it. So easy in SPSS. What is the data set that we are going to use for today's class? Now, the sample data set basically look at the scores out of 10 of 4 subjects: English, reading, mathematics, and writing. But for this class, I'm going to focus on English and mathematics. You could try your hands on comparing reading and writing. Before you conduct any test, it is always important to do a descriptive. And more important, in a typical statistics class, you must test the assumptions and to ensure that the assumptions are not violated. Because if some of the assumptions are violated, then you look for an alternative, probably a non-parametric test. For the descriptive, in SPSS, you go to Analyze, Descriptive Statistics, and you go for the descriptive. Of course, you select your variables, English and mathematics, and these are the main that you get. So, how do you interpret it? You say the mean English score is much higher than the mean mathematics score. Again, the case is what 409 case with non-missing English score. 422 case with non-missing score for mathematics, but only what 398 case with non-missing observation for both variables. Again, you can also go to Analyze in SPSS, compare descriptive statistics. This time you explore. You add your English and Maths to the dependent box and click on Display options to plot. Click on Plot buttons and then look out for the box plot. And again, you can change the selection to dependent together if you want to. You can uncheck the stem and leaf. And then you click on Continue and you click on OK. Voila. Before I display this in SPSS, this is the output you are likely to get or you must get. Now, for mathematics, we see some outliers. Likewise, for English, there are some outliers. If you have an outlier, you must first investigate whether these are true outliers. And if they are true outliers, the best approach is to do away with outliers. If they are true, if they are not true outliers, then you have to go through some rigorous data management process, because outliers will negatively influence your p-value and the accuracy of your p-value. Now, whilst reporting, you must report these outliers, that you had what outliers in the data set. But despite this, you must also look at it and tell us that both variables appear to be symmetrically distributed. And when they are symmetrically distributed, then it implies there is very much a likelihood that the t sample test will come out what's significant. And this is the pictorial view. Analyze, compare mean, pair sample t-test. And then you move the first variable to variable 1, and then the second variable to variable 2. These have all been explained. Now let me quickly go through the SPSS. So in SPSS, analyze descriptive statistics and select descriptive. We are interested in math and English. So I select it beautifully. Do I want anything apart from what has been selected? No, I think it's good. Click on OK. And this, voila. Just as is reported. Look at the minimum, look at the maximum, look at the mean. Very important for you to report them. Again, we went to analyze, descriptive, and explore. What are we looking out for? We are looking out for English and mathematics. Okay. We can come to plot. We can check stem and leaf, but I would prefer leaving it. We have our statistics. We can check for outliers if you want. And then our options, we would keep it as it is. We do both. Okay. So not so much interested in all these results. But you see, for English, this is our outlier. 55, it points directly to where the outlier can be located. And 268. And these are the other outliers, 88, so 214 and 333. Then for mathematics, what do we have? For mathematics, let's move down and look for its outliers. Voila. So 80, 358, 419, and then 351. Remember, if these are true outliers, it is better to do away with them. Again, this is the lower width, and this is the upper width. This is the mean, the first quarter, and this is the third quarter. The mean is also known as the second quarter. Voila, once you are done, let's see how best we can perform the pair sample. So analyze, compare mean, pair. So I select my English first, then this is followed by my math. But if you can check to see if you want to change the confidence interval, but I would want to maintain it at 99. I think I am virtually done. Click on this, and this is what you have. So it gives you it gives you the descriptive, and second, it gives you the pair correlation, which is very weak but significant. Then it gives you the pair sample t-test. Remember, this is the difference in mean. So 88.7441 minus 66.4468 will give you 17.29726. That is the difference. Again, these are the differences in standard deviation and the standard error. Look at the confidence interval. It is usually all are positive, so there's a likelihood for it to be statistically significant. The t-value says it. Look at the degree of freedom. Remember, we've come across degree of freedom before, and these are the significant level, which means it is less than, at a two-tail, it is less than 0.001. Less than 0.001. Let's go back to our slides. So these are all the steps that have been explained, which I've done. Again, the output. The pair sample t-test. It tells you the sample size is 3898. Why? Because the pair sample t-test can only use cases that have non-missing value for both variables. So it can't do with cases that have missing. Any missing will be excluded so that it will be paired at the same level. That is why your N for both maths and English are the same. The pair sample correlation, it shows a bivariate Pearson correlation. And then there are what? There's a two-tailed sum test. And it is what? Significant as well. But the correlation value is weak. So this is a weak positive or a positive weak correlation between what? Maths and what? English. And again, we report the mean. The mean difference, as has already been explained. Likewise, the standard deviation and the standard error differences, the confidence interval, the t-value, the sig, and which is at two-tail. And remember, it is less than 0.001. So how then do we conclude? From the results, we can conclude that English and math score were weakly and positively correlated. And this is how you write it. You say there was a significant average difference between English and math score. And on average, English score were higher, right? That is it, because the doing difference was positive, and it was what? Approximately 17.3. And then you tell us what the confidence interval is, the ranges. To the layman, what does it mean? It means that the scores that the individual attain from math and English are not the same. It means significantly there are differences. And these differences are not because of chance. And these differences can be or should be investigated if you are curious to know. But if if the result was not significant, then we say it is because of chance. And because it is chance, you do not necessarily have to spend a lot of time investigating, because we don't build ourselves on chance. Okay, fellow students, colleagues, what are the takeaways? One, you must know the definition. Two, you must know the assumptions. Three, the data requirement. Four, you must know the SPSS procedure. And most importantly, you must know how to interpret your results. Simple, straight to the point. Thank you very much for watching this video. And please do watch over and over again if you need more knowledge and understanding. I'll see you in the next video. Bye-bye.